Hi everybody, we are going to do some more practice with factoring and solving quadratic equations with some Regents questions. So if you guys take a look at number one, I'm going to give you guys about, I think 5 or 6 questions, and then I'll give you a practice sheet with 5 or 6 questions that are really similar. So number one was a Regents question a few years ago, and they say, okay, Amy solved this equation, 2x squared plus 5x minus 42 equals 0, and she stated that her solutions were 7 over 2 and negative 6. Do we agree with her solutions? So we have to know what we would be able to do with solutions to explain yes or no. So one thing you could do with solutions are the x values. You could plug them in to see if it works. In other words, literally, I could have you take your equation. You would have to do it twice. 2x squared plus 5x minus 42 equals 0. And I could plug in 2 times, instead of 7 halves, I could use 3.5 squared plus 5 times 3.5 minus 42 equals 0, and check to see that it works. You could pull up GeoGebra, okay, as easy as this, and say, okay, let me put it in. You could use 7 halves as well if you wanted to. If I wanted to show with 7 over 2, I could square it plus 5 times that 7 over 2 again, or 3.5, and then minus 42. Does that equal 0? Okay, yep, I know that works. 0 equals 0. And then I can do it one more time with negative 6. I could show that 2x squared plus 5x minus 42 equals 0. And I could plug in my solution of negative 6 every time I see a 0. Every time I see an x, sorry. And I would also, if I did that again, okay, to prove to you, I could do 2 times negative 6. I'm going to square it, plus 5 times negative 6, and then minus 42. And I get 0. So I could literally say she's correct because when the solutions are substituted in for x, so I'm going to say that this is one option, okay? Option 1. Yes, Amy is correct because when she subs, I'm just going to say subs in for x, both sides equal 0, or they equal each other. So that's one definite option. Okay, so let's talk about another way you could do this. You could full-blown solve it, which I know a lot of you have been struggling with, so let me just show you this. I could take the equation 2x squared plus 5x minus 42 equals 0. Okay, and this is a tough one because you have no GCF. So you would have to multiply 2 times 42, negative 42, and get negative 84. So now you want to ask yourself, name some numbers that multiply to 84. So again, not the easiest number. So literally, this is what you could do, okay? If I go here and I clear everything out and I say to myself, okay, I have negative 84, I could divide it by x. And I could go to my table of values. I don't know, go from negative 20 to positive 20. Find a whole bunch of numbers. I need my two numbers to be two numbers that are going to have a difference of 5, right? That's my middle term right here, positive 5. And I see it right there. It's got to be 12 and 7. They'll give me a difference of 5. So if I want it to be positive 5, I'm going to say, wait, what was it? What were my two numbers? 12 and 7. Okay, so let's say positive 12, negative 7. Okay, so now I'm going to split my middle. I'm going to keep my 2x squared. I'm going to put my 12x first, my negative 7x second, bring down my minus 42. And now it's grouping, double grouping. So we're going to find our GCF of these first two. It's got to be 2x. Divide by 2x. I get x plus 6. The GCF here, my negative has to come down, and my GCF would be negative 7. Divide them both by negative 7. I get x plus 6. I know I'm right because these match. So one of my factors is 2x minus 7. The other one is x plus 6. And because they're talking about solutions, I got to go that one step. I take 2x minus 7 equals 0. I take x plus 6 equals 0. Here, to move this to the other side to get x by itself, I get 2x is 7. And when I divide by 2, there's your 7 halves. That's exactly what they said. And on the other side, I minus 6 from both sides, and I get x equals negative 6. So you could easily say, I agree with Amy's solutions, because when I solved it, I got the same solutions, 7 over 2 and negative 6. So a couple of ways. Now let me be very honest. Another way you could do this is pull up GeoGebra. Okay, there's no reason you can't also type in the equation 2x squared plus 5x minus 42. Okay, and you're going to have to stretch out, but what are the solutions? It's right here where the graph crosses the x-axis. Look at that first root, negative 6. Look at the other root, 3.5. Done. You could say, I put the equation in my calculator and I look to see where the graph crosses the x-axis, and I would say the graph crossed the x-axis at 3.5 and negative 6. Done. You just proved that those are your solutions. Okay, so a lot of ways to do it. Okay, I'm going to go to the next one. They want you to solve algebraically. So if we're solving algebraically, the first thing I'm seeing is I'm going to take that 2m and distribute it to m and to 4. So that's going to give me 2m squared plus 8m equals m minus 3. And it's a quadratic equation. Your highest exponent is 2, but it's not in standard form. So I'm going to minus m from both sides. Now this one's interesting because when I minus m, this m is gone, but these two are like terms. This becomes 2m squared plus 7m equals negative 3. Now it's still not in standard form, so now move that 3 over. Now there's no like terms with that 3, it's just going to go to this side. 2m squared plus 7m plus 3 equals 0. And now you have, once again, this split the middle. There's no GCF between 2, 7, and 3, which means you're going to multiply 2 times 3 and get positive 6. And this is an easy one. What multiplies to 6 and adds to 7? 1 and 6. So we keep our first term, we keep our last term and our 0, and we're going to split 7m into 1m and 6m. Remember, the variables go with it to split 7m into those two numbers. So group, GCF here is 2m. Nope, can't be 2m. Why? This one doesn't have a 2. So the GCF can only be m. When I divide each by m, I get 2m plus 1. Here, this number has to have a positive in front, and the GCF is 3. So when I divide each of those by 3, I get 2m plus 1. Okay, so I know I did it right. These match. That means one of my factors is 2m plus 1. My other one is the two GCFs, m plus 3. So now, again, they want to solve for m. What would m equal? Take each factor, set it equal to 0. So to get m by itself, move the 1. 0 minus 1 is negative 1. And when you divide by 2, m equals negative a half. Here, easier, m equals negative 3. So those are your two solutions, a half and negative 3. Okay. Let's try another one. Okay, let's go blue. Ooh, this one's going to be tough. So it says y minus 3 squared equals 4y minus 12. So immediately, to simplify y minus 3 squared, you need to show this. Y minus 3 times y minus 3 equals 4y minus 12. So in my head, you could either do double distribute there or the box method. I'm going to just show some double distribute. I would get y squared minus 3y minus 3y plus 9 equals 4y minus 12. So these two in the middle are like terms. They don't cancel out. One would have to be a plus and one would have to be a minus for them to cancel. They become negative 6y plus 9 equals 4y minus 12. Now, we never, ever, ever want it to equal 4y minus 12. We want it to equal 0. So I'm going to move the 4y underneath. You see where I moved it? Underneath the 6y, because those are like terms. That cancels. And minus 6y minus 4y is minus 10y. But that still equals negative 12. Add that 12 to the other side. So now I have y squared minus 10y plus 21 equals 0. And now I'm ready to factor. Nice, easy trinomial. What two numbers multiplied it? So you don't have to do crazy split the middle here. When this number in front, there's nothing there. It's technically a 1. You just say, okay, what multiplies to 21 and adds to negative 10? And you bring your y's down, and it would be a minus 3 and a minus 7. So if I bring that up here, because I'm running out of room, y minus 3, y minus 7 equals 0. To get my solutions, set each little mini factor into an equation. Here I would add 3. Here I would add 7. So here y equals 3, and here y equals 7. So notice, again, from factor, these are the factors. These up here are the factors in parentheses. From the factors to the solutions, these are the solutions. You'll also see the word roots. The signs change. They were both negative in the factors and they become positive. You could also put that in the calculator and check. When you see that in the calculator, you'll see the roots are at 3 and 7. Okay, let's try this guy. I'm going to go purple. Okay. So in this next one, they say write an equation that defines m of x as a trinomial and then solve for x when m of x equals 0. Okay, so let's talk about this one. You have parentheses next to each other. Everybody sees this. You have to do a double distribute or set up a box. So I'm going to say m of x equals, so 2x times 2 is 4x. 2x times negative x is negative 2x squared. Negative 1 times 2 is negative 2. And negative 1 times negative x is positive x. That was a tough one. Now don't forget the plus 3x squared plus 8, because we're going to now combine. So look for some like terms. I see negative x squared, negative 2x squared with 3x squared. I see 4x with positive x. And then I also see negative 2 with positive 8. So let's combine some like terms. I'm going to go standard form, so your highest exponent first. Negative 2x squared and 3x squared is just 1x squared, or just x squared. 4x and 1x is 5x. And negative 2 plus 8 is 6. And you've answered, here's your first question. There is your trinomial. 3 terms, x squared plus 5x plus 6. Now the second part says, what about solving for x when m of x is 0? So that doesn't mean plug 0 in for x. It means the whole thing. 0 is x squared plus 5x plus 6. Well, if you don't like it there, which I feel like most of you don't, I don't even like it there, it's going to make it go on the other side. So now factor this basic trinomial. What two numbers multiply to 6 and add to 5? Most people are going to say, oh, 6 and 1. But 6 and 1 would add to 7. It's got to be 2 and 3. Set up your t, x plus 2, x plus 3, minus your 2. So x equals negative 2. Here you're going to minus 3 because it's a positive 3, so x equals negative 3. And there are your solutions. It's really nice to show this, negative 2 and negative 3, in a solution set, not parentheses. They're not x's and y's. It's not a point. They are both x values, which means it goes in a solution set. Okay, here we go. We're getting down to the last couple. This one's tough. It says if f of x is x squared and g of x is x, determine only the values of x. Okay, so only they want the x values. And this is what it means, only x values, when f of x equals g of x. Okay, when f of x equals g of x, well, what's f of x? X squared. What's g of x? X. When one equals the other, just set them equal to each other. I would say set equal to each other. Okay, so now people will say, oh my God, what am I going to do with this? Well, what do we always do? Make sure it equals 0. Does this equal 0? No, it's quadratic. Exponent is 2. Move this x to the other side. Now, when you do that, these are not like terms. It's x squared minus x equals 0. And people will say, what am I going to do? That's not a trinomial. But what should you look for first? GCF. What do they both have in common? X. So when I divide each of those by x, I get x minus 1. Divide, divide. And now you're done. Set your two factors, x and x minus 1 equal to 0. This one is done. One of your solutions is x. This one I have to, move the 1 to the other side, and x equals positive 1. So you, once again, have two solutions, 0 and 1. And hint, as long as you have an x squared, all of these are x squared, how many answers do you have? 2, 0 and 1. Up here I had two answers, negative 2 and negative 3. Here I had two answers, 3 and 7, okay? If you have an x squared, which is quadratic, you should have two answers. Okay, this last one should be really quick. If she wants to know her zeros are the same thing as solutions or roots. And they say her solutions are negative 3 and 9. Okay, these, look at how they're giving them to you as factors. So what happens between factors and solutions? The signs are opposite. In other words, think about this. This means if I wanted to work backwards, it means x had to equal 3, and negative 3, and x equaled positive 9. Those were your solutions or zeros. So think about this. What did her factors have to be? Hopefully you know it's the opposite sign. So inside here it should have been x plus 3. And up here it had to have been x minus 9. That should be what you're looking for. Minus 9 plus 3, there's your answers. And if you, let me show you how you're going to check. If you put that in the calculator, right? So if I clear out what I had and I put in x minus 9 in parentheses and x plus 3 in parentheses, okay? Where are my solutions or roots? Look at that root, negative 3. Check. That's what we got. Look at this root, positive 9. Check. Okay, that's how you're going to check your answer. And again, it's just opposite signs, factors to solutions, factors to roots, opposite signs. Because if I took x plus 3, set it equal to 0, x minus 9, set it equal to 0, what would you do? You would minus 3. Here you would add 9, and you would get x equals 9, x equals negative 3. Okay, hopefully that helped. I'm going to give you guys a little practice sheet, and you're all set. I hope you have a great weekend.